Good everyone, welcome to I Square Maths Academy, where numbers and variables actually meet mastery. Yes, in our last class, we actually looked at integration of this form. Yes, integral 1 all over a plus b sine square x plus c cos squared x. Yes, c cos square x. Yes, c cos square x. Here we have the x. Yes, we actually looked at this and we said to analyze integration or integrals of this form, yes, all you need to do is to substitute. Yes, is to substitute t is equal to tan x. Yes, t is equal to tan x to analyze integration in this form. Now, today we are going to be looking at integrals in this form. Yes, integral the x all over a plus b sine x plus c cos x. Yes, now if you look at this is actually different from this. Yes, this is actually different from this. If you look at this function very closely, you will see sine square, cos square. So functions with square, yes, sine square, cos square can be analyzed using t to be equal to tan x, or substituting t to be equal to tan x rather. But in this case, you discover that here there is no square here. So when you have integrals in this form, all you need to do is to substitute. Yes, is to substitute t to be equal to tan x all over 2. Yes, we call this half angle substitution. Yes, or Weierstrass substitution. So now we're going to look at some examples now. Yes, let's look at example 1. Example 1. Yes, solve integral the x all over, yes, we have 1 plus sine x minus cos x. Yes, 1 plus sine x minus cos x. Now, if you look at this very closely, it's actually different from this. There is no square here. So because there is no square in all these functions, it means we are substituting t is equal to tan x all over 2. So here, solution. So you substitute t to be equal to tan x all over 2. Yes, t is equal to tan x all over 2. Now, if t is equal to tan x all over 2, it therefore means that, yes, if t is equal to tan x all over 2, it therefore means that the t, yes, the t all over the x will be equal to, now this is a function of function. Yes, because this x all over 2 has actually taken the position of x. Yes, the standard function is t is equal to tan x. Yes, because this x now has been replaced by x all over 2, it means we have to treat this as a function of function. Yes, just like having a bag inside another bag. So it means in this case, the t all over the x will be equal to, we have sec square x all over 2. Then you multiply it by the derivative of this function. Yes, and of course, when you differentiate x all over 2, it gives 1 all over 2. So it means the t all over the x will be equal to 1 all over 2 sec square x all over 2. Yes, that's the t all over the x. Now, if the t all over the x is equal to this, it means the t will be equal to half sec squared x all over 2. Then we have the x. Yes, so making the x the subject, the x will be equal to the t all over half sec square x all over 2. So it means the x will be equal to the t all over half. Yes, any number, any value divided by half is 2 times that value. Yes, 2 divided by half is 2 times 2. 5 divided by half is 5 times 2. So it means the t divided by half is 2 the t all over, here we have sec square x all over 2. Yes, then recall, yes, tan square x plus 1 is equal to sec square x. So it therefore means that sec square x all over 2 is 1 plus tan square x all over 2. Yes, tan square x all over 2. So it therefore means that here, sec square x over 2 will be equal to, we have 1 plus. Remember, we substituted t to be equal to tan x all over 2. So it means to get the value of this tan square x all over 2, we have to square t. So here we have plus t square. Yes, plus t square. So it therefore means that here the x is equal to, we have 2 the t all over, we have 1 plus t square. Yes, because this says square x all over 2 is 1 plus tan square x all over 2. And this tan square x over 2 is t square. So here, let's look at this now. So if t is equal to tan x all over 2. Yes, if t is equal to tan x all over 2. Now let's bring out our right angle triangle. Yes, so the given angle there is x all over 2. Yes, and we have it as t. Yes, now let's recall. So, yes, here sine is opposite all over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite all over adjacent. Yeah, so here we have all over 1. Opposite is the side that is facing the given angle. Yes, we have all over 1 because this t is the same as t over 1. Now let's call the side z. Yes, let's call the hypotenuse side z. Now from the Pythagoras theorem, we all know that the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. So it means z square is equal to, we have t square plus 1. So z square, yes, z square will be t square plus 1 because 1 square is 1. So z will be equal to t square plus 1, the square root. Yes, the square root. So it means this is the square root of 1 plus t square, or t square plus 1. Yes, the same thing. So now in this case, the value of sine x, let's see the value of sine x. Now sine, yes, sine x. Now this sine x is the same thing as sine half x plus half x. Yes, that's x all over 2 plus x all over 2. Now from compound angle relationship in trigonometry, yes, we all know that sine a plus b is the same thing as sine a cos b plus cos A sine B. Now let's take note of this. Let's take note of this relationship. Yes. So it therefore means that sine x, which is the same thing as sine x all over 2 plus another x over 2 will be equal to sine x over 2 cos x over 2 plus cos x over 2. Then here we have sine x over 2. So it means the whole of this now, since this and this are equal, it will give us 2 sine x over 2. Then here we have cos x over 2. Yes, sine x all over 2 and cos x all over 2. So here we have 2. Now let's see the value of sine x over 2. Now sine is opposite all over hypotenuse. Yes, opposite over hypotenuse. So it means sine x over 2 will be opposite t all over the hypotenuse. That's square root of 1 plus t square. Then let's look at the value of cos x over 2. Cos is adjacent over hypotenuse. Adjacent over hypotenuse. It becomes 1 all over the square root of 1 plus t square. Yeah, so the whole of this now will give us 2 times t times 1. That's 2t. Divide by, remember, the square root of a times the square root of a is equal to a. Yes, the square root of 5 times the square root of 5 is 5. Square root of 100 times square root of 100 is 100. It means the square root of 1 plus t square times the square root of 1 plus t square is 1 plus t square. So therefore, sine x is equal to 2t all over 1 plus t square. Now let's take note of this. Yes, let's take note of this. Yes, let's take note of this. Now let's look at cos x. Now cos x will be equal to cos, we have x over 2 plus x all over 2. Yes, cos x all over 2 plus x all over 2. I remember from compound angle relationship in trigonometry, cos A plus B is the same as cos A cos B minus sine A sine B. Yes, cos A plus B is the same as cos A cos B. Yes, please take note. This is B. Is cos A cos B minus sine A sine B. So it therefore means that here cos, please let's take note of this again. Let's take note of this. So it therefore means that cos in bracket x over 2 plus x over 2 will give us cos x over 2, another cos x over 2 minus sine x over 2, then we have sine x over 2. So now this is the same as saying cos square x over 2 minus sine squared x over 2. Now already we have seen the value of cos x over 2. We say cos x all over 2, that's adjacent of our hypotenuse, is 1 all over the square root of 1 plus t squared all squared minus, now we have sine, opposite of our hypotenuse. We have t all over the square root of 1 plus t squared. Here we have all squared. So squaring this, 1 square is 1. This square will give us 1 plus t squared minus t squared is t squared all over this square. That will be 1 plus t squared. So the LCM of those two is 1 plus t squared. This into this is 1. 1 times 1 is 1 minus this into this is 1. 1 times t squared is t squared. So it means cos x over 2 plus x all over 2. Now, which is the same as cos x. Now, let's take it from cos x. Cos x is equal to cos. We have x over 2 plus x over 2, which is the same as 1 minus t squared all over 1 plus t squared. Yes, all over 1 plus t squared. So now cos x is equal to 1 minus t squared all over 1 plus t squared. Now let's take note of this again. Yes, so now we have, yes, we have this and we also have this. Okay, we have sine x and we also have cos x. So now it means from the question we are looking at, yes, we are looking at 1 plus sine x minus cos x. 1 plus sine x minus cos x. Yes, 1 plus sine x minus cos x. Yes, that's what we have here. Okay, now looking at 1 plus x minus cos x. 1 plus sine x minus cos x rather. That's what we have here. So now let's look at this now. So here we have 1 plus, let's look at the value of sine x. Now the value of sine x, we have 2t. Yes, we have 2t all over 1 plus t squared. Yes, minus cos x. And cos x is 1 minus t squared. 1 minus t squared all over, here we have 1 plus t squared. Yes, 1 plus t squared. So it therefore means that here, let's look at this over 1. So the LCM here will be 1 plus t squared. So 1 into 1 plus t squared is 1 plus t squared. Yes, times 1. We have 1 here. Then plus 1 plus t squared into 1 plus t squared is 1 times 2t. We have 2t minus 1 plus t squared into this, it will give us 1 times this. So we have 1 in bracket 1 minus t squared. So it means 1 plus sine x minus cos x will be equal to 1 plus t squared plus 2t minus 1 plus t squared all over 1 plus t squared. So here 1 plus sine x minus cos x will be equal to, now let's look at this now. 1 will go with 1 here. 1 minus 1 is gone. We have t squared plus t squared. That will give us 2t squared plus 2t all over 1 plus t squared. So it means the whole of this now will be equal to, we have 2t squared plus 2t all over 1 plus t squared. Now let's figure 1 all over this function. Now 1 all over 1 plus sine x minus cos x will be equal to 1 all over, we have 2t squared plus 2t divided by 1 plus t squared. Yes, the whole of this now will be 1 plus t squared all over 2t squared plus 2t. Yes, plus 2t. So it means here we'll have it as integral 1 all over 1 plus sine x minus cos x will be, the x will be equal to, we have integral 1 plus t squared divided by 2t squared plus 2t. Then now the value of our dx. Yes, the value of the x. Now remember we said the x is equal to the t all over 1 plus t squared. Yes, all over 1 plus t squared. So it means here integral 1 all over 1 plus sine x minus cos x dx will be equal to, now this will go with this. We'll be left with integral the t all over 2t squared plus 2t. Yes, integral the t all over 2t squared plus 2t. And now this is the same as saying integral the all over 2t in bracket t plus 1. Yes, t plus 1. So it means we'll have it as 1 all over 2 integral the t all over, here we have t in bracket t plus 1. Yes, t in bracket t plus 1. So in this case, this is the same as saying 1 all over 2. Now let's split this into partial fraction. Yes, let's split this into partial fraction. Now let's split that 1 all over t in bracket t plus 1. Yes, this is the same as saying a all over t plus b all over t plus 1. Yes, b all over t plus 1. Now let's look at t is equal to 0. Now let's look at, using the cover up rule. Using the cover up rule, yes. Now let t be equal to 0. Now let's close this now. If t is equal to 0, now let's close this. So if you close this, it means our a will be equal to 1 all over 0 plus 1. That will give us 1 all over 1, which is equal to 1. Yes, which is equal to 1. Now let's look at t is equal to minus 1 now. Yes, let's take t to be equal to minus 1. Yes, t to be equal to minus 1. Yes, now we are taking t to be equal to 0 because here we have just t. Yes, now when t plus 1 is equal to 0, it means the value of our t will be equal to minus 1. When you take plus 1 to the other side, it becomes minus 1. So now let's put or substitute t to be equal to minus 1. Yes, when you're taking t to be equal to minus 1, it means the value of our b now, yes, this b now will be equal to, you close this now. Remember when we pick t to be equal to 0, we close this. We actually cover this. Now we are taking t to be minus 1, we are covering this now. So now we have 1 all over minus 1, which is the same as minus 1. So it means integral, half integral the t all over t in bracket t plus 1 will be equal to half integral, yes, half integral, we have a over t, and the value of our a is 1. So we have 1 all over t minus, yes, because the value of b now, remember here we have it as plus, but the value of b gave us minus. It becomes minus 1 all over t plus 1. Yes, then here we have the t. So it means the whole of this now will be half in bracket. When you integrate 1 over t, it gives ln t. Yes, ln t minus ln t plus 1. Then here we have plus c. Yes, plus constant. So here this is the same as saying 1 all over 2 ln, we have c all over c plus 1. Then here we have plus constant. So here we have 1 all over 2 ln. Now remember the value of t. We actually substituted t to be equal to tan x all over 2. So it means here we have tan x over 2, yes, divide by tan x over 2, then here we have plus 1 plus constant. So this is the solution to this problem. Thank you so much for listening.